For the problems 5 through 7, we need to determine the sample size needed to estimate either a proportion or a mean. And it's important to note which one you want to use because that changes what formula to use. The formulas are given on the exam, but you can see in problems 5 and 6 we're working with a proportion, and in 7 it's about a mean. So we'll use one formula for 5 and 6, and then 7 is a different formula. So the formula for 5 and 6 is that the sample size n is equal to our preliminary estimate of the proportion, which is p, times 1 minus p, or p hat, and then this is multiplied by z sub alpha over 2 divided by the margin of error. And in these proportion problems, the margin of error will be a percentage. So you'll be given something like a margin of error of 4%, and then you'll need to change that to a decimal 0.04. So the reason why we have two questions on proportions is because sometimes you're given a preliminary estimate and sometimes you're not. So in problem 5, we are not given a preliminary estimate for the proportion, so we use 0.5 in that case. So I'm going to multiply 0.5 times 1 minus 0.5. And this is just the most conservative way to go. It'll also result in the largest possible sample size for the scenario that we're given. So it's nicer to have a preliminary estimate. It means you don't have to have quite so large of a sample size. Then we need to multiply by the value z sub alpha over 2. So we're going to have to actually calculate that. So what we do is we say, well, it's a 90% confidence level that we're looking for here. So I'm going to sketch the normal distribution, and what we're saying is we want to be 90% confident when we do the problem. So the question is, what is z sub alpha over 2? Z sub alpha over 2 is this value right here. So it's a boundary value. That means we're going to use the inverse norm formula, or inverse norm function of the calculator. Since this is 90% in the center, that means that there is 10% left over, 5% in the upper tail, 5% in the lower tail. So 5%, which is 0.05, you enter that. So we take inverse norm of 0.05, and that gives me a negative, which is actually this value here, but because we can just take the negative sign off of there, and that gives us the positive side, so z sub alpha over 2. So we can drop the negative. If we forget to, it doesn't matter because we're going to be squaring anyway. So if we square the negative, then we're going to end up with a positive anyway. So really, if you don't remember to drop the negative, it doesn't matter. Now, it tells me in the problem to round this value to 2 decimal places, so this would be 1.64. Oops, 4. And then we have the margin of error in the denominator, and that's 0.04, and we square, and here's the calculation typed into the calculator, and we get 420.25. Now, because we're talking about sample size, we can't have 1/4 of a person, and this is minimum sample size. It means 420 isn't quite enough, so we have to go with 421. And so that's the answer for problem 5. Now, in problem 6, let's see. I'm going to erase all of this. And, oh, come on. Now in problem 6, we want to be 95% confident. So that means if there's 95% in the center, That's 2.5% in each tail, and that's why we use inverse norm 0.025. And the mean is 0, standard deviation is 1. Some of you don't need to enter that. Everybody with the stat wizard will have to enter that. So we've got a z-value of 1.96 when that's rounded to 2 decimal places. So we've got that in our formula here. And in this case, we do have a preliminary estimate of 0.27. So we get 841 and change, which means 842. So we're not looking to round, really. We're just going up to the next whole number. And now for problem 7, we're going to use the formula n equals z sub alpha over 2 times sigma, the standard deviation, over the margin of error, and this whole thing is squared. So we calculate z sub alpha over 2, and we get 0.01 for the value that we have to put in here. So our z value is 2.33. So we use that 2.33 times sigma divided by the margin of error. Notice that we don't have to change that to a percentage this time. Square the whole thing, and we get 965 and change, which means 966. So that's how to do those sample size problems.